Hi everyone, wish you a very good day today. Today our topic will be very interested and it's very basic, it's cloud computing. We'll explain today what is cloud computing and how it started, and we will carry on about the cloud provider and what is the services that they can provide. First of all, allow me to introduce myself. My name is Mahmoud Miari. I'm working as head of operation for ICT more than 17 years, and also I working as a professional coaching for training engineers with several fields like networking, cybersecurity, clouds, and much more. And these are my websites and my YouTube channel. So the accomplishment for the day, we will do a refreshment of computing, what is computing, how it started, and why is the cloud computing. As well as we will talk about cloud computing vendors and the concepts of cloud computing and the services all over the world. So it will be starting with the computing concepts uh, and the vendors and the services that they provided. Great. First of all, I'd like to take the concept from the beginning. The beginning is very simple, and I'm talking about like many 30, 40 years back, is PCs with the computers and they are connected to each other and some information going here and there. So when starting a need for like computational calculations and all these stuff, then we need supercomputers that can do these processes together. And the name is supercomputers or mainframes. Because our normal computers was not handling the big computationals and statistics for that. Uh, then the computers became like a little bit advanced, and we can do something like HPC, and we will talk about it. Uh, but where the problem is when it comes to the evolution that we have with our smartphones and all this stuff and the using for the social media. Then the situation became more complex and more complex. So especially when it's come to Internet of Things, that the home automations and controlling your home electricity with the AC and many things, and either your refrigerator, your CCTV, your access control, you can connect it from locally or from outside. This is mean like from using the cloud. So the scenario was being like very difficult. And especially the number and amount of data that's going here and there over the cloud is unpredictable and is going exponentially for that. So here also became with us another topic. It's called like big data and how this data should be processing and computing for that. So the conventional like IT, it came with normal servers in the IT, and these servers, it will be like doing some processes and computings, maybe parallel or maybe serials. Uh, but we came to know that there is also a problem and limitation for this computing. So we need a help. After that, after virtualization came up, then we can like virtualize servers and to do it like with sub servers. So with these sub servers, we can distribute the computing processes among these servers. And also we stuck with some limitation. We will talk about this limitation in this series. Then the cloud computing came. And the cloud computing is something on the cloud that you cannot see. It has like a very big supercomputers and servers, and you will rent these services as per your need. How these services will come and what's your need will be, we will cover it in this series. But before that, let's talk about the computing machines and how it's coming. Before it was calling HPC or supercomputers. They have the same terminologies. The HPC is high performance computing. It's a shared pool of resources over the network. Then we can combine all the CPUs and we will do our computing, okay, through this HPC. Uh, it was coming with several types of that. It's serial computing and parallel computing. The serial computing was event by event or task by task. When the task came, the share of these pools of the CPUs will do the processing and computing for that. After finishing it all completely, then after that it will take another task. But with the parallel, it came to solve the serial limitation for like task by task. So we need something like multitasks to be there. So the parallel computing came. So if I have, for example, 10 processing I want to make, so it will achieve this simultaneously at the same time. So it will do the computing at the same time and it will finish as per the amount of the computing services or tasks that I sent. All these was like working in a very limitation. But when it's coming to computing, like a huge computing, like today is the big data and data analysis, when we need like to do a huge analysis from a different source of data. So this style of computing will not help us. Then we will need for a farm of servers, too much servers, so we have to invent and to pay more and more to achieve the computing that we need. And maybe what we achieved is for this special or specific task or specific assignment, let's say. But what about if I have another assignment and this assignment need for more computational theoretical things? Then we will go for endless point that we will need like server farms to be bigger and bigger and to do that. And what I'm saying that this is something will cost you millions. It will cost you like the hardware itself for the hardware and will cost you also its operational cost like the engineers and the technician that you need to manage this infrastructure for you. And also you need a lot of power resources to power on these server farms that you have. And also you need a very expensive and a professional cooling system for these servers to be maintained properly. And we need like many things. So here we are talking about capital expenses and operational expenses. The capital expenses that I need is a huge expense that it needs to be paid upfront to buy the servers and the switches and all this stuff and the infrastructure for that. And I need the operational cost also, it will be high because I need different level of expertise to maintain and handle these server farms or data centers, we call it sometimes. So this is something not feasible because we are nowadays in an environment that the technology is going exponentially and every day there is like something new. So here we need to know like what is the need of a cloud computing? A cloud computing generally, when you are doing a cluster of servers and you combine them together to unify the capability of your infrastructure, and this is you will share it with your team or with your clients. So this is actually you made a cloud for yourself to serve others. Maybe others will be like your employees, maybe you'll be your clients, whatever. So a good example for that is your server room in the organization or the data center in the organization. If you can check it, you will find, for example, you have 20 physical servers, and these servers are combined to each other in a way, maybe virtualized or anything, to serve your organization, to serve your business. So this is your cloud or a private cloud or an on-premise cloud. So now I hope the idea is clear. So let's go to see what's cloud computing right now. A cloud computing is a model to enable ubiquitous, convenient, on-demand network access. What does on-demand network access? Is whenever I need the service, whatever the service is, then I need to access this server. From where? From a shared pool. Why it's called a shared pool? Because in the data center, whatever the data center now, we are not talking about the cloud, okay? Now talking about we did our own cloud. So shared pool because there are several servers, and from this server I'm going this servers or this service. So this is a shared pool because it's talking from physical server for that. Okay, of configurable computing resources such as I'm giving you what? I'm giving you like network, server, storage, applications, services like you need like to do like computational things. You want to achieve some mathematical algorithm and it's need for high CPUs and high powers, then I can give you whatever you want. And these services should be rapidly provisioned and released with minimal management effort or service provider interaction. When we mention minimal management effort, now this cloud cannot be locally, cannot be the cloud that we open, like something called OpenStack, okay, that I'm doing my on-premise cloud. Then why it's not minimal effort? Because still I need operational cost. My operational cost will be high. For example, I need some engineers who specialize with the servers. Another engineers who specialize with the virtualization. Another engineers who specialize with networking and like switching and routing in networking infrastructure. Another engineers will be like with firewall and securities and endpoint protection and all these. I need some technician levels for connectivity and cable maintenance and installing and reinstalling the devices. I need many management capabilities which is cost me too much. Great. So when you go day by day and year by year, we figured out that there is a cloud computing, and this is why cloud computing over the cloud came. They have three main models: a private cloud, and I explained in a while that you will be having your servers and the cluster of servers for high computational and services in your premise, locally in your premise. Public cloud, this is what our topic will be, like to have a public cloud on the cloud with the cloud providers. Then I can take the services from the cloud. And we might go for something called hybrid cloud for a reason, to connect the private cloud with the public cloud in a way. For example, if I have my cluster, I have servers and all this stuff, and I need the storage to be in the cloud, but all the processes and the user management and user services will be locally on the premise, but only I want to take a backup, and this backup will be like on the cloud. So in this case, my on-premise, my private cloud, should be connected in a special way with the public cloud that will achieve for me the hybrid cloud. Great. So cloud computing services model. In the traditional IT, as I explained, everything we need to manage it, and we need a high operational cost for that, because we will be responsible for the infrastructure, and the infrastructure is the network, the storage, the server, the virtualization. So with this here, I need different capabilities of engineers to handle this. Moreover, I need for something called a platform. So there should be a platform engineer who's responsible for example, expert in SQL, expert in programming to do like some application for computational services, or to do like any ERP system or HR and payroll management system. This will be like resides in the middleware and the operating system, the Windows operating system that I'm working, maybe Windows, maybe Linux, it depends, and the runtime environment. And there is another thing for the traditional also. It's not like, it's about software. Then the software will be responsible for the application and data for that. So all these traditional, it will be responsibility for your organization with your team. So all the headache is that. But with the cloud, we have the three main concepts or model services. It's called infrastructure as a service, platform as a service, software as a service. IaaS, PaaS, SaaS. What is infrastructure as a service? In infrastructure as a service, you will be responsible for only the the cloud provider will be responsible only for the infrastructure. The cloud provider will give you the storage, will give you the networking connectivity from the switching. It will give you the servers. If you have virtualization, he will give it to you also. But the platform and software, this is your responsibility. So here, if you can see like a cloud provider will be responsible for the infrastructure, and the platform will be responsible, and software will be responsibility for you. It's like something called test development, storage backup, and disaster recovery. When you go to like platform as a service, the cloud provider will be responsible of infrastructure and the platform. He will put for you, for example, the coding environment and the programming environment for that. Maybe you need just to do a computational processes that will need for that. Then the best practice for that is analytics and business intelligence and development framework. The software as a service, everything is maintained by cloud provider, from infrastructure, platform, and software. You as an engineer, you will be responsible for nothing. For example, Microsoft Teams for the meeting is an example of SaaS. Skype is responsible for SaaS. OneDrive is responsible for SaaS. One more thing is Zoom, the Zoom meeting. Anything that it's on a cloud, you are only using it. You just communicate, you will do this. Even now, the software that I'm recording this from, it's on a cloud, so it's SaaS, software as a service. For me, just I press the recording button and I start talking. I don't care about where this software installed, how many capacity of the storage that is run on, what are the services, is it on virtual environment or physical dedicated, what is the operating system and or the middleware this software is run on. All this information, I don't care about it. I care about the software that I'm using. Click, I'm recording, click, I'm stopping. So the cloud service provider are many, like Amazon is one of the top cloud provider for that, as well as Azure. They are like sharing the market. We have also Google Cloud has a good solution. Huawei Cloud has a very great solution also, and services. We have Alibaba, we have many brands now it's coming for that. But for this cloud, they have a lot of data centers. In these data centers, there are special companies preparing for that, needs for a huge server. You're needing for a huge switches and routing and firewall infrastructure. And one of the best company who's preparing this for AWS and Azure, like Cisco. Cisco selling like Nexus switches for them, UCS server also for them. These are specialized and designed for data center. So when we are talking about cloud computing services, it's too much, but the main thing is the compute where I'm doing my infrastructure. It's like VMs, virtualizations, containers, and we also rent a network. It's a classic network and virtual network. We will talk about them both. And also it is about the storage, type of storage is block storage, file storage, or object storage. So before doing that, what is virtualization? When we are doing a computing was doing in, as I told you, supercomputer, and after that called HPC, high performance computing. And now it came like servers, and the server specification became very high. But the server as a physical server has limitation. What are the limitations for that? Also, we care about like some difficulties and limitation. It is scalability. There is no scalability and flexibility to upgrade the server. Why? If the server I want to upgrade the hard disks, then I need to go for operational process with my company. For example, I need extra hard disk and extra RAM. So I'll apply, and I'm in need for that because there are applications running on the server. And I found that the hard disks are getting full, and the processes are too much, and the RAM cannot also handle. So I apply for my manager to that I need to upgrade the hard disk and RAMs. Then the manager approve it and send it to the procurement department. I want to tell you the process is very simple. Some company the process is complicated. Then the procurement company will start asking us for technical specs. We will send the technical spec. They will see like 3 or 4 suppliers and asking for prices, and they start negotiating. After that, we'll place the order. If the hard disk and RAMs available in the market immediately, then it's our luck. If not, it will take maybe 1 week, 10 days for that. So to upgrade one hard disk or 2 hard disks or some RAMs, memory, I have to go for a process, and this process maybe to take for me 1 week, 10 days, 2 weeks. It depends. So there is no any scalability for that. So what will be happening is we said, okay, thanks God there is virtualization. The virtualization, we will be having a physical server. We will buy it from the first time it's with good resources. And after that, I can divide it to sub-servers or virtual server inside it. Maybe if we are talking about something called Active Directory to manage users and computers. So I will create a server with a specific specifications like hard disk and RAMs for Active Directory. And I'll create another server for DNS, another server for file server, and a server for storage. Great. So this is optimize the things. But again, what if, don't forget that this virtual images is taking resources from the main, the physical server. What if the physical server resources run out? You don't have more. So again, here I need another server. And of course, when we're talking about server, it's not one server. It should be like 2 or 3 servers for redundancy to achieve something called redundancy and resiliency. So you will find yourself that you are paying too much. Why I'm paying too much? Because I need servers, and I need storage, and I need infrastructure. And this is infrastructure require power, require cooling system, require firefighting system, like something specialized for the server room and data center. It's called FM200. And it needs also redundant electricity, something called bus bar. And it needs like a special raised floor with frustrated, and many things it will need. So it will cost me upfront capital expenses, and also it cost me operational, even with the virtualization. And virtualization solved me a limitation for that, then I can scale up a little bit. But again, this scalability is very limited. That's why the benefits for virtualization is that I can partitioning, I can do multiple VMs, and each VM is isolated from each other. Okay, so I do partitioning, I do isolation, and I can do encapsulation, so VMs is stored in a virtual system as files, so you can migrate VM by cutting, copying, and pasting files. So if I have a VM machine, then okay, copy the files for that, and go to another virtual machine or another VM environment, import this file, then you will be having all in all the server with the specification, with the hard disk, with the application, with everything. Agreed. Independency, after being migrated to another physical server, a VM can properly run without any modification on server because VM operating system decoupled from physical hardware. So this is the beauty with virtualization. But again, there is a limitation. Limitation of specs of the main physical server. So the virtualization, if we can see it here, we have a physical server. How the physical server is working, it's called host machine also. We will install operating system on it, and after that, we'll install our applications on the server. For example, I have a physical server. I installed Windows Server, and after that, I start install some website. I install application like Active Directory, DNS Server, whatever. With the VM, it's something else. I have a host machine, and I have layer of virtualization called hypervisor. This is anyone is working with virtual environment, it has to work with this layer. It's called hypervisor. And there are many companies doing virtualization, like, for example, VMware, this company, and it's a product called EXI. There is Microsoft doing virtualization, and it's a product is called Hyper-V. Hyper-V is different than hypervisor. Hypervisor is the technology that all the vendors are working on it. Okay, Hyper-V is for Microsoft, and there is for IBM, there is for many companies. So how this physical machine, hypervisor layer, and after that I start creating my guest machine. So, or my VM, virtual machine. So my VM, guest machine is the same with VM. So my VM will be on this physical server. I can create another VM, but there is condition here. The limitation is the equal VM resources should match the physical resources that I have. And if I have hard disk 1 terabyte, I cannot create a VM and I will tell him I need a hard disk with 2 terabytes. 2 terabytes for VM is greater than the 1 terabyte from the physical VM. So always you should be down. Great. So why computing resources is around us? Because we need a lot of processes and all these. So especially when we go to in the ICT environment, that I have several resources need to calculate data and obtain information. So need for high computing for that. So we need high memory, we need high CPU, we need high GPU, we need high RAMs. RAMs mean memory, the same. We need also storage like hard disk and many things. So what computing services is done for me, it's doing for me like something called VM. It's called ECS, Elastic Cloud Server. Some cloud vendor is naming it EC2, like Amazon. Microsoft is naming it as virtual machine. It depends. It's giving me something called auto scaling. It's giving me something called load balancing. It's giving me something called IMS, image management service. So again, from virtual environment, we go to something called container. What is virtualization is, when we are virtualizing, we are virtual the whole machine itself. Okay, so we'll be having a very big file. The file is heavy. But when it came to the container is a lightweight portable technology for application packages. It's a standard unit that can package application code and all its dependencies, enable application to run across different computing environments. Simply put, containers are like standardized boxes that can hold different types of things and put into different cabinets. For example, if you have a container, this container, when you want to back it up, you back a raw small files. So even the files will be in kilobytes or megabytes. Then it's very light. When you want to import it, so it will be importing in seconds. But the VM is very heavy in compared to container. So when you see the difference between containers and VMs, the container architecture is infrastructure and host operating system, and there is a container layer. There is no hypervisor layer. Container layer, and after that, virtualize the software, the operating system, the application. Here, application A, B, C, D, E. But with the VM, I have the infrastructure the same, but here I have hypervisor layer, the virtualization layer, and after that I have the whole VM. Inside this VM, I have the operating system, I have the applications, I have whatever I want. That's why it's heavier than the container. So, if we want to make like a quick brief of container and VM, the startup speed, the container startup in seconds, VM need minutes. Virtualization type, we are virtualizing the operating system, but in the VM, we are virtualizing the hardware itself, and that's true. I have a physical hardware. What I'm doing a virtual machine is I'm taking from the memory, I'm taking from the CPU, I'm taking from the hard disk. So I'm virtualizing the hardware itself. Operating system dependencies, all containers share the host operating system. Each VM runs its own guest operating system. Security, here process isolation with security risk. There is security risk. VM is complete isolation, so the security is higher than the container. Isolation strategy, hypervisor, and with the VM is C groups. Image size, it will be like kilobyte to megabyte, and with the VM is gigabyte to terabyte. Virtualization performance, on-bare with physical servers, and for the VM is limited. Why limited? Because if you run out from your physical resources, then you cannot virtualize more. Per machine capacity, over 1,000 containers for each physical machine, imagine. But for VM is dozen of VMs. Yes, dozen of VMs because it will be a limited form. So in the container part, what is the cloud can give me? Can give me also cloud container services, like called CCE, and have cloud container instances, CCIE. And we have SWR, the software repository for container. This is the middleware between the CCI and the ECC. Compute services for the network. Basic concept of conventional network, like in our traditional, we have for the network, we have the cables, and inside this cable, we have the switches. When we came to virtualization, there is a concept called network switches. Then I can virtualize the network switch. And also I can do a something called VLAN, virtual VLAN. Then I can segment my layer 2 infrastructure. And after that, moving the VLANs through a wire called the trunk. In the VM, I can do the same in the VM, and it will be like virtual switches. And this is the concept of virtualization for the network. For the conventional network devices is router, layer 3 switch, network interface card, and layer 2 switch as well. These are network components in the traditional IT. So with that, with the network interface card also, this is most important element in the network, that this is the network interface card that connected to the network switch. But we can virtualize it, yes, everything that it has a virtualization for that. Basic concept of virtual networks, I have a virtual switch. This virtual switch is connecting to the virtual machine. And I have types of virtual network. It's like a bridge, even the virtual network, I make it a bridge, or NAT, or something else also custom. So what is a bridge? If I have my physical server and it's connected for the physical network interface card, and I have, for example, an IP address called 192.168.1.0/24, this is a network. Then if I choose the virtual switch or virtual NIC to be bridge, then it means I'm telling him, give me for my virtual machine from the subnet of the physical server. Great. If I want to isolate it, I want to work in different subnets, so I will use NAT type. NAT type, if my physical machine network is 192.168.1.0/24, I can make the NAT for the virtual machine for me, and I can put it, for example, the subnet is 200.1.1.0/27. Okay, it will be completely isolated network from the physical subnet. So, how the virtual switch that we have several types for the virtual switch. It's called OVS and EVS. So the virtual switch is I can divide my switch, my physical switch, to a virtual switch as per the virtualization environment. Here we are talking, be careful, we are talking about normal virtualization. The same concept will be in the cloud now, and we will see what the cloud can give it to us. So in the cloud services network, we have a virtual private cloud VPC, could be like that. I have NAT gateway, I have elastic IP address, I have load balancer, I have something called auto scaling, also these under category of network. What is this? The VPC is the same of the switch, network switch in reality. It's called VPC, Virtual Private Cloud. For example, Azure is call it VNet. AWS is called it VPC also. And I need also NAT gateway that I need my servers on the cloud to go to the internet. So I need for the gateway, even the cloud can give it to me. I need elastic IP address. It can give me like a real IP address. Of course, you know that the difference between public IP address and the private IP address. So real IP address, that this IP address I can reach my server from wherever I want. After that, it will give me a storage. Storage in a traditional way is a block storage, file storage, and object storage, as we know. So a block storage is maps the entire raw disk space to a server. For example, 5 disks in a disk array can be divided into several logical disks, and it's called RAIDing. We have RAID 5, RAID 1, RAID 6, RAID 1 plus 0. We have too much. That I have hard disk, and these disks, I can combine them logically to each other to maximize the space and do a redundancy as well. So for example, RAID 5, minimum I need 3 hard disks, so 2 will be active and 1 will be as a spare. If one hard disk damaged, the spare one will continue the job without any distortion for the server. So block storage is ideal for most data storage scenarios. Great. What else I have? I have file storage, and this is file storage. It's normal shared storage in the environment that will be having a server, and this server will be having file, and this file will be accessible for everyone over the network. Also, I have object storage. This object storage for something called structured and unstructured data. To be honest, the data, it has too much types, okay? And one is called structured, semi-structured, and unstructured. Structured data is normally the data that it's organized in columns and rows. Okay, so this is called structure. Like the tabular things, it's called in the Excel. that you have column on row. This is structure, something organized. This is easy to store, easy to retrieve, easy to abstract data from it. But the unstructured data and semi-structured is difficult. The type of unstructured is like video. When you have a video, you want to store it. This is stored as unstructured data. There is no any tabular format for it. Voice, pictures, all these is difficult to do. So object storage is widely used in scenarios such as data backup, images, video data, storage and website hosting, all these. So in the cloud storage, I can have like EVS, Elastic Volume Service. The Elastic Volume Service is the hard disk that will be mapped to the server itself, or the virtual server, or the ECS if you are talking about the cloud. Then if I am, my storage is full and I need another hard disk, in matter of seconds I can give it and put it inside. Also, they have scalable file service SFS, and it's like the same of shared file that I can do if I have multiple VMs on the cloud and I have shared files, then I need all the computers to share these files and to access it. And again, I have something called OPS, the Object Storage Service. This is responsible for unstructured data storage for that. Great. Also, I want to talk about some concept before ending this series, that why is cloud computing, after explaining all these terminologies? Because cloud computing is, for the big scale, you will find it is more cheaper than the traditional IT. How? If you have a big server room or data center, you will invest too much money, as we explained. You need to take care for the power. So power consumption bills will be for you also. Also, you need cooling. You need manpower. But imagine everything is on a cloud. So it's easy. So if I want to make a scalability, I want to upgrade, then in seconds I will upgrade. Rather than to check, even like if my organization is very fast. Maybe this hard disk now or RAM not available in the market. Need 2 weeks to be come there. So maybe it will be for business loss or business stop if I run into a very serious problem. Not only that, but also the management is very few. The security is very high. Everyone now, if anyone like in terms of security, has something called ransomware that can come and decrypt your files. If you are in locally, you will not do anything if you don't have a proper backup. But if you have with the cloud, then they will rebuild your VM machine in seconds and make it up and running for you. Also, more benefits of that, as I mentioned, we have something called load balancing and we have something called auto-scaling. What are these? If you have a website, you put it on the cloud, and this website is an e-commerce website. Great. And you want to make a promotion for 2 hours for example, iPhone mobile. It's $2,000 and you want to crash the market and you want to make it like $800. You will not be able to predict the amount of traffic that it will come to your website within these 2 hours. It will be incredible. You will not be able to know how much RAM your servers will require or need, how much CPU processing your server need. You cannot do that. So, and also the traffic when it's coming is coming from one single source. So what is the solution for that? Both technologies, auto-scaling and load balancing. Auto-scaling is a mechanism that you will put a threshold. For example, if my RAM utilization reaches 60% and my bandwidth utilization reaches 70%, create another VM for me. So it will create another server temporary for you Then you will be having two servers. What the load balance is doing? When the traffic come, the first traffic he will put in the same server, another traffic he will put in another server. But what if the problem is still there? If the threshold is still there, he will create another server for you. So now we'll be having three. So the load balance will have three paths to share. First traffic on the first one, and it's equal. Second one in the second server, third one in the third server. This is a mechanism called round robin. So it will do that. What we will ensure is our website, the e-commerce website, is up and running. No any problem with it. But with the traditional, I cannot predict how much, or no one can predict how much traffic will be there, how much utilization will be there. So what about if the promotion is done? The threshold, when threshold is coming down based on something called pool time, then he will start to delete the first server, not the original one, the last server he created. After that, still the threshold down, he will delete the another VM. After that, it will stay for you hard disk, the original server that you have. What about the payment? The payment here, pay as you go. And this is one of the strengths of cloud computing. I don't need to pay too much. They have, of course, pay as you go. They have monthly, they have yearly. But if you cannot predict, then I can use this. Then in these 2 hours, they will tell you, okay, the utilization for you is, for example, $200. Then I will pay for this $200. So now everything in the cloud. One more thing. We are using social medias here and there. Facebook, Twitter. There is one studies said that the data is generating from one single mobile per month is something in zettabyte. Zettabyte is an incredible number. So this also need for cloud computing and need, this is called big data, by the way, and big data should be processing in a cloud computing. You cannot do processing in normal things. So how the cloud providers will assure for me the service? Very simple. It's based on regions. Every service provider like AWS or Azure or Huawei, they'll be having covered major regions that you have. Inside the region, that's called availability zones. Availability zones mean data center. They keen to have 2 or 3 data centers per zone to serve you better. And they will tell you, please, there'll be a note. You want to take a server, choose the nearest region to you. Why? To avoid latency. Then the traffic will be high. If the traffic will be high, then the service will be very easy for me and I can reach it. Second thing, I can reach my server and my services anytime. I don't have to be in the server room. I don't have to do a complex configuration like VPN and all this stuff. If I'm here today or tomorrow in another country, then I can access my resources 24/7 and anything. This is actually all about cloud computing concepts. If you want to know more, you have to go now deeper for cloud services, one of the providers like AWS, Azure, Google Cloud, or Huawei, to study their courses and to start doing the business or migrate your business over there. I would like to thank Tidra Virtual Academy for giving me this opportunity to give you this a comprehensive series about the cloud concepts and what is the difference of the cloud concept and cloud computers and how the ICT infrastructure will be there. Hope to see you in other courses and thank you very much.